How does dew point relate to precipitation? Imagine standing outside on a humid day and feeling the air get heavy and damp. That sensation is closely tied to the dew point, a key part of how water moves in our atmosphere. The dew point is the temperature at which air becomes saturated with water vapor and condensation begins. When the air cools down to this temperature, it cannot hold any more moisture in vapor form. This causes water vapor to turn into tiny water droplets, which is how clouds start to form. As these droplets gather and grow larger, they can fall as rain, snow, or other types of precipitation. In the water cycle, warm air rises and cools as it ascends. This cooling can happen in several ways. For example, when warm air rises and expands, it cools through adiabatic cooling. It can also cool when it touches a colder surface or loses heat through radiation. When the air cools to its dew point, the water vapor condenses onto tiny particles called condensation nuclei, like dust or salt. This process creates clouds. As more vapor condenses and droplets grow, they become heavy enough to fall as precipitation. The dew point is a critical marker for when this process begins. If the dew point is close to the current air temperature, the atmosphere is nearly saturated, making rain or snow more likely. If the dew point is much lower than the air temperature, the air is drier, and precipitation is less probable. This is why weather forecasts often mention the dew point. It helps predict whether rain is on the way. You might notice dew on grass or condensation on cold bottles. That happens because surfaces cool below the dew point of the surrounding air, causing moisture to condense. In the sky, when warm, moist air cools to its dew point, clouds form, and precipitation can follow. So, understanding the dew point helps explain how and when water in the air turns into rain, snow, or other forms of precipitation. It's a simple but vital part of how water moves through our environment and sustains life on Earth.